Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to solve a second order linear differential equation with real roots. So let's take a look. The problem then before us is solve y double prime plus 3y prime plus 2y equals 0 with y, and this is the null solution. I'm not going to label it because there's no particular solution, with y null equal e to the st. Now we're going to use what we've already learned. And we know right away that the characteristic equation in this is going to be s squared. Oh, let me just show you this. We said in general it's a s squared plus b times s plus c equals 0. Well, in our case, a is 1, so this gives us an s squared. I'll show you. Let me do that in green. So here's the 1 for the a. If I grab this blue, here's the b. That's the 3. So the b is the 3. So plus 3s. And finally, if you have this yellow, the c plus c. C is the 2. The 2 in front of the y, the coefficient of the y. So plus 2 equals 0. Now, we could put this into the quadratic equation if we wanted to. It also happens to factor, so let's do that. This is s plus 2 times s plus 1 equals 0. And there we have it. So we'll say that s1 is 2. And S2 is negative. Oh, sorry. S1 is negative 2 and S2 is negative 1. You should speak up when I make a mistake like that. Well, here we go. So we can write our final solution then as y equals, or I'll put this as, remember, this is a null solution. So this is C1 e to the minus 2t plus C2 e to the minus, I'll write the 1t, but after that we'll just write minus t. So let's give this some initial conditions. Say we have our initial conditions are y of 0 and y prime of 0. How do we use those? Well, here's how it happens. So y of 0 means the t's become zeros. So this becomes C1 e to the minus 2 times 0 plus C2 e to the minus 1 times 0. Well, we know that e to the 0 power is just 1, so we're left with y of 0 equals C1 plus C2. Okay. Now, for the next initial condition, we need to use our y prime of 0. So first I need y prime. Well, y prime is going to be minus 2 C1 e to the minus 2t. So I'm just taking the derivative of my null solution right there. That's what we're going to do. I'll put the null if it helps. And then we're going to have minus C2 e to the minus t. Okay, there's our derivative of the null solution. So now we evaluate it at 0. I'm not going to put the null. That's what we're only talking about. So this first term, we have an e to the 0. That's 1. So I have minus 2c1. The second term, e to the 0 is 1. So I have a minus c2. And now what I have is a system of equations. So I'm just going to write my first equation. Y of 0 is C1 plus C2. Notice that if I just add these two equations, then I'm going to get, if I add, so if I take y prime of 0 and I add it to the equation, or I just add the whole rows, goodness, then I'm going to get y prime of 0 plus y of 0 equals minus C1. Because minus C2 plus C2, well, that's 0. So there it is. We've solved it. So I'm going to write this as C1 equals minus y prime of 0 minus y of 0. Okay. And now we just substitute this in to find C2. I'll use the second equation. So I have y of, I'll write that. Substitute C1 into y of 0. So I have, what do I get there? So now I have y of 0 equals C1 is minus y prime of 0 minus y of 0 plus C2. If I move these terms to the other side, I have y prime of 0 plus 2y of 0 equals C2. There it is. And right now I can then write my final solution, which is going to be y null equals C1. So this is minus y prime of 0 minus y of 0 e to the minus 2t plus my C2, well, C2 is y prime of 0 plus 2y of 0 e to the minus t. And that's the first solution with real roots. This is the first solution with real roots. I think we'll stop there. I hope that helps. And thanks for watching.